toxins. And I think, given what we're seeing around cougar, there's actually a connection that we'll talk about between fire and toxins. So what I was going to do is give you a little background on what harmful algal blooms are and toxins, and David, please jump in if I go sideways. And then kind of what happened in Salem and here at home this year, and it's still kind of going on. And then looking at the future, kind of what is going to exacerbate this in the future, and talk about climate change and wildfires. And then what is being done, what are we planning for now, what are we doing now, what are we planning to do in the future to try and respond to these kind of blooms in the future. So this is probably my wordiest slide because I want to make sure I define this right. But blue-green algae are actually not algae at all, but single-cell organisms called cyanobacteria. They're photosynthetic bacteria. They share properties with algae. They're found naturally in fresh water and seawater. And some of them do produce toxins, not all of them. And so when they do produce toxins, they can impact human health. And so the basic conditions that allow these blooms to occur is, of course, you need sunlight, you need intensity and duration of sun, you need nutrients, you need warm weather. There's also some about higher pH tends to help blooms. If you have precipitation events that start bringing in new nutrients into the system. And then you have slow-moving water, stratified water, and then you have a zooplankton population that isn't eating everything as it starts to bloom. And so, when you think about it, this is, I got this out of an engineer who was doing this talk up in Salem. But basically, even back in 1671, they were talking about these blooms, these toxic blooms, where essentially green substance that caused certain and sudden death to cattle and dogs. So some basic facts about cyanobacteria is it's one of the oldest life forms, been around for over 3 billion years. It occurs obviously naturally in the water and on the terrestrial. And there's over 7,000 species that we know about, but that probably represents half of what is actually out there. And they're, because they are photosynthetic, they actually helped create the Earth's atmosphere back billions of years ago. So clearly these guys have been around a long time, and they've been producing toxins. So this isn't not anything new. 2018 is not the start of something new. And some can fix nitrogen, and they all need phosphorus. And obviously they have the capabilities to kind of move their buoyancy up and down based on the best conditions for them to grow. And so there's really two families, I like to call it. One is a suspended, and then the other is the benthic. And so this you see on the rocks in the rivers, and up until recently, we didn't really think the benthic could actually produce toxins, but some work we're doing at the USGS is starting to show that this can produce toxins. What we're used to is, of course, the stuff floating on the lakes that does produce or can produce toxins. And this is just an example of, you'll see a lot of slides of these guys, but it is the vegetative followed by the heterocyst and the ankinid, and I guess the heterocyst is the nitrogen producing, is that right? And then these guys are the ones that I'll show you in the next slide, kind of drop off and seed for next year. And so here's essentially the life cycle, is that you have germination, it starts growing the vegetative cells, then you have the nitrogen fixing cells start to develop as the summer warms and there's more light, and then the heterocysts form, which are essentially going to seed for next year. Then they go dormant, and then it just keeps on going around. And so as you have blooms, they seed, and then if the conditions are right, blooms happen again in the next year. And so these are essentially the toxic suspended. These are the ones on the lakes, essentially the species that we see. Slenderospermopsis is the one that we have been dealing with this year. But Microcystis and Gloria trichria are fairly similar too in this area. Anabina is also another one that we've been seeing in this area. And then, of course, the benthic ones, which are the ones in the river on the rocks. Nostoc is one that we see around actually our intake, and David just told me that you're seeing some of this also in the lower part. So the stuff is prevalent throughout, and it's really not knowing what makes them produce toxins and when they start producing toxins. That is something that we really don't know at all.
There's actually a Nostoc Creek in the H.J. Andrews Federal Park.
Wow, wow. Did not know that. And from a drinking water perspective, basically, they're hard to treat, and you saw that with Salem. They essentially produce a lot of dissolved organic carbon when they die off, and then that gets into the system, and when we treat with chlorine, that actually creates disinfection byproducts, which are carcinogenic. And they create, obviously, taste and odor issues and turbidity, and they can clog up intakes. And they mess with, essentially, pH cycles and DO cycles. So this slide is, I'm not going to go into this, but basically it shows of the genus of the algae that multiple toxins can be produced by any one of these. So like Slenderospermopsin, which is what we are seeing, can be produced by a number of different algae. And then, of course, really it's neurological or liver is kind of the main impact from these toxins. So the challenge with these guys are that they pass through treatment systems, obviously, and which I'll show you in a little bit from the data we got in cougar, is that they really don't correlate. If you have a lot of cells, essentially, a big algal bloom with thousands, tens of thousands of cells, they may not be producing toxins, but if you have a small, where water looks fairly clear, they can be producing toxins. And they're essentially happening way upstream from intakes, like in Detroit and cougar. And essentially, when you treat some of these, they can actually lyse the cells that then release the toxins. So if you're adding chlorine, that can actually create more problems than you started with. And so this is just a little test. Which of these do you think actually has toxins in it? This is obviously a loaded question. But, it's not this guy, it's not this guy. So you can't really look at it and say, oh, that's a problem. It is a problem, obviously, but maybe it's not producing toxins. So you really don't know where the toxins are when they're being produced. So that's kind of my quick and dirty background. I'll pause there. Are there any questions for, now I'm going to go through Salem and Eugene, and yeah.
How easy to test for them? Is it
the testing
process, or is it easy?
It is fairly easy, yeah. And I'll talk about that a little bit later as we get into what we're doing and how we're doing it. But there is it's called ELISA. It's an assay test, which helps you, you can quickly determine whether you have toxins or not. One of the problems is at the levels that you can actually see from those tests is about the level where you have human health impacts for vulnerable populations. So, when you can actually see the detection limit, you're already in a position where you have a problem. So, and I'll talk more about that a little bit. So this is a Salem system. For those of you who don't know, they get the water out of the North Santiam. They take it out at Guerin Island. They have a water treatment plant there, which I'll talk about a little bit, and then it flows into a number of communities in Salem. And the problem or the difference between their system and ours is clearly they have a big reservoir at the top of their system. We have reservoirs on major tributaries, and we have a nice clean river that is diluting those tributaries as they come in. They don't have the luxury of that. So when they have a big toxic algal bloom, it essentially is impacting the river. And these slides are from the city of Salem, so I'm borrowing these. I'm not an expert on this, clearly. But in early May, this is kind of what areas of Detroit Lake look like. They started clearly having a bloom occurring on a number of the arms and along the dam face. And this is kind of what happened. On May 8th, they noticed the algal bloom on Detroit Lake. They started ramping up their sampling for toxins. On the 25th, they actually got data that showed that they had a detection above the health levels. And immediately they called the Oregon Health Authority and said, we have a detection in our finished water above health guidance levels. And basically what the guidance levels for human health are set at is assuming that you have a 10-day exposure. And so they call this 10-day cushion, like, okay, we saw this toxin, And if you start drinking that, it actually wouldn't affect you unless you drank that for 10 days. And so this is supposedly to allow utilities to adjust their treatment during that 10-day period to try and take care of it. So they made the operational changes. They also activated their wells, a different source of water. They start using that. But the problem is that the source of water that was coming from their wells was being transported on transmission main. This is transmission main line number 2, which then had a large leak. And so to compound their problem, they're using their wells, but then they can't get that water in because they have a transmission line problem. So they go back to surface water to keep up with demand. Then they started sampling daily. And so they started trying to repair the transmission line, and then they issued their advisory on May 29th after EPA and OHA basically informed them that, yes, you need to issue an advisory. And so when you look at this, so they knew they first got the toxins on the 25th, but by the time they told the public, it was 4 days later, and they took a lot of flack for that. And partly because this caught everybody off guard, because we have never had one of these before. And so OHA essentially was kind of learning on the fly, and so just to give you, so the way Salem's system works, which is very different than our treatment system, is obviously they have an intake, it goes through some pre-treatment, and then it goes through some slow sand filters on Gare and Island. It then is disinfected, fluoride is added, it gets a corrosion control, and then it goes into town. And so the system of the slow sand filters is one that is once, and they've had problems with turbidity, they've had problems with diatom die-off, and it's not very effective in treating for toxins either. And so they had some issues with it, and I heard that they got some toxins actually being produced in the slow sand biological filter itself. So the filter got infected essentially with toxin-producing bacteria. And so now that's, as far as what I heard, I don't know if that actually kind of was confirmed later, I don't know. That's what we were told. And so what came out of that is that there's problems with the guidelines, with the health guidelines, with this 10-day thing, which is confusing to explain to the public. But then they didn't communicate, it was clear in hindsight that just being up front, as soon as they got toxin hits, they should have been communicating that to their customers. And they also, I don't know if you remember, but they had an emergency alert that went out to not drink the water, but the emergency alert was basically, this is a civil emergency. Do you remember what it was?
Yeah, I mean, it was some like emergency notification that didn't specify that it was the water.
It didn't say it was the water, it just said it was emergency and kind of be very afraid. But so people started freaking out. And actually, and then there's a run on bottled water in stores. Actually, one of our staff, Jason User, lives in Salem. He's our legislative liaison. And he was telling a story about his wife, he thought they had enough water stored up. His wife told him, no, go to Fred Meyer, get some more. And so he drove to Fred Meyer. And he said he pulls in the parking lot, and there's cars just parked everywhere, like not in the parking spaces, but just people stop their car, get out, and run into the store. And so he's like, all right, so he parks, kind of walking into the store, people are running by him. He gets in the store, and there's shopping carts parked everywhere. And, people are just, there's no water left, and so people are yelling and screaming. So he's like, all right, no water, he gets turned around, walks out. He's walking out, and he sees a car, like, leaving the parking lot, hitting the gas, slams into another car in the intersection, pushes that car into a fire hydrant. Fire hydrant blows up, starts shooting water into the middle of the intersection. And he's just like, it's like chaos everywhere. He just gets in his car, goes home, but So that's what was happening basically on the 29th. All hell was breaking loose. And Salem didn't realize that they hadn't actually informed their staff out in the field about what was going on. So their staff were being accosted by the public and saying what's going on, and their staff, their people of the field crews didn't know what was going on. So they're like, I don't know, So that created more confusion. And then they started getting calls from places like the hospital or can we do surgery? food manufacturers, senior homes, so what does this vulnerable population mean? Can we not do surgery, cannot do this? So then they realized that they didn't really have answers for that, so then they talked to OHA didn't know, so it created a lot of immediate confusion. They eventually obviously got things under control and were able to write out the problem. But in answer to Dana's question, there's really two ways to look for toxins. One is through LCM, SMS, mass spec, and then the other is this assay method. And so one of the problems is that you take a sample, you send it to the lab, it takes 2 days to get to the lab, maybe a day and a half. They run it, you get the results maybe a day or two later. So you have like a 3-4 day lag from the time you take the sample to when you get the results. And so if you get toxin hits, you already know that you've lost 3-4 days in that 10-day window. And so that was creating problems for them as well, just the delay in actually getting information. And so that's the Salem story the best I know. I think I tried to represent it as truthful as I heard it, but they clearly know more about what happened, so there's just something I did. So for us in the McKenzie, basically what we were doing starting in May is every year we go up and we do sampling for algae. And where we sample, well, not this location, but essentially we do here, and actually David, we don't have a South Fork point here, so I added this little dot. But anyway, so we sample here, we sample an outfall, we sample 2 places in Blue River if there's blooms happening, the outfall to Blue River, and then we sample at our intake. And so we started monitoring, and then the Salem thing blew up. And so we realized, and at the time that we were monitoring, we were getting these kind of, so this is a logarithmic scale on this side for cell counts. This is total cells of an algae, essentially. And so you can see that these are the action levels that we have. Way up here, like 80,000 is where you start actually having an action level. Once you, in the past, what would happen is if we get this hit here, we would then start looking for toxins. So that's the way we did it in the past until we had, I got a laser. Much better. All right, so, so when we have these, that's when we started looking for toxins. In the past, we never looked for toxins when we were getting this kind of cell count. And so clearly, when that happened at Salem, we immediately started looking for toxins in our water. And we were having cell counts down here, but what ended up happening is, and this is kind of a little bit of a confusing graph, but I will explain. So this is where, so we were getting toxins, basically. So even though we were not getting the cell counts, we started getting hits of toxins, and this is South Fork, and this is Blue River. And these levels, this is essentially the health advisory for child vulnerable population, and if it's in the drinking water, this is the health advisory for adult population, this is recreational, and then this is dog, essentially the level for recreation for dogs. And so, and this is basically the lowest the lab can see it is right here. And so you see that, so we weren't getting very high cell counts, but then as soon as we sampled for toxins, because what happened in Salem, we found them, which then we immediately started sampling at our intake. And so this is obviously in May, and you can see we got a hit at raw water, basically in late May. And then we started sampling basically every 3rd day. As soon as we got the results, which we get like in 3 days or 4 days, we would then sample again, and we kept getting hits. And this result is questionable in that I think it should be a slow line down, but there is a interesting result that came out here, which is, whether it's real or not is still a question. So you can see we got hits at the raw water intake, and we started sampling the intake and our finished water. We never found it in the finished water, but it gave us quite the scare. But the difference is that we have a treatment system that we can actually readjust and address toxins in many different ways. And so we can turn off pre-chlorination, because what happens is when you have toxic cyanotoxins coming in and you have chlorine, it actually lyses those cells, and then the cells can release the toxin. And so you don't want to chlorinate when you know you have toxins coming into your system. So we turned off the chlorination, we started adding activated carbon, and then after it went through our filters, we added a higher dose of chlorine on the backside to kill toxins that were coming out of the filters. And that seemed to work. We have data that shows that that treatment was effective at varying trace levels, which we couldn't see from the lab results. And this, I hope you can guess this. So after we started looking at this, what we realized happened, because we haven't seen toxins in the past, is, so this is the outflow from Cougar. And so you see they started opening Cougar up, and this is essentially the percent contribution from Blue River and Cougar at Vida. So you get the total flow at Vida, then you look at how much flow is coming out of Blue River and Cougar, and how much does that make up of the river at Vida, if that makes sense. And so what we found was normally at this time of year we're getting like 25% of flow is in the McKenzie is coming from Cougar and Blue River. But during this period we had almost 55% of the water in the McKenzie is from Cougar and Blue River. And while they're having a toxic bloom, and so essentially they're dumping these toxics into the river, and the river's not able to dilute them like we probably have seen in the past. And this was happening because of South Fork, obviously. So you're doing a South Fork project, which was great. But just like when they put in the temperature control tower for fish, it does impact drinking water. So a lot of so fish and drinking water quality doesn't always go hand in hand. But so you can see that here we're getting, these are basically, we're not getting cyanotoxin hits. They open up Cougar, and then all of a sudden we're getting cyanotoxin hits in our drinking water, or in our raw water. So this is something that we have talked to the Corps about. Eric Peterson and Greg Taylor, met with them a couple times, and I'll talk a little bit later about kind of what we came up with as far as thinking to try and minimize this from happening in the future. And then after what came out of all this, in June was Oregon Health Authority came up with a new set of rules. I'm not going to walk you through this. As you can see, it's a fairly complicated set of steps we now need to go through. So there are rules now requiring us to monitor every 2 weeks for toxins. And so you do your intake every 2 weeks, and then if you get a hit, it puts you into this flow chart where you're doing daily samples, or you ramp up to weekly and then daily, and a whole bunch of stuff. So now you have basically 180 utilities around Oregon or so that are now going to be sampling for toxins every 2 weeks that never sampled in the past. And so it'll be interesting over this next year. This is the first year collecting all that information, kind of what we see in the future and how much more we're going to be aware that toxins are out there when we didn't know before. So that was the result of this whole effort, was now we have new rules on the book that we have to start paying attention to. So as we look into the future and we see that we're losing our snowpack from climate change, temperatures are rising, this clearly has an impact on what blooms are going to happen in the future. And it's probably some of the reasons why we're seeing what we're seeing today. In that, this is research I think I've talked to this group about in the past. It's stuff that Eric Sproles did at OSU, where essentially you're losing that snowpack. You're going to have more precipitation coming in the winter as rain, and you're going to have a longer, drier summer. And so because you have higher temperatures, longer, drier season, those are perfect or better conditions, we'll say, for future blooms to occur. And this is just something that I like to show this graph just because it really paints the picture of what situation we're in. And this is for extreme hot weather in the northern hemisphere. But what you see is this is 10-year periods. You see all these are different 10 years periods. And this is a normal distribution of essentially extreme hot weather events, which means that when you get out to these shoulders in the past, this is where you have the 120-degree days, the extreme droughts. And so in the past, you would have, let's say less than 1% chance of some extreme event happening. And this is actual measurable data. So now what used to be like a 1% chance of extreme event happening is now essentially 11 to 12% chance. And so now that you have this increase of now it's becoming normal for some of these events to happen that we never saw in the past. And we have no idea now what the 1% looks like. And so it just adds that uncomfortable feeling of we don't know what's coming, but we know that you get in these cycles and nature hits these trigger points where it sends it into a reoccurring loop that makes things even worse. And fire is one of those things. So clearly you have a longer, drier fire season. In the summer, vegetation stressed, you have more fires. It's clearly showing up across the west. I don't think there's any disagreement with that, I hope. And we're now starting to see that wildfires actually is a source of nutrients to reservoirs. And so and I'll talk about this in a little bit, we're working with OSU to start trying to develop a study that actually looks at this with the Terwilliger fire. And when you have increased nutrients, you have increased blooms. And so I think there is a relationship around fire and blooms. We don't, there's not any real good research out there that actually says that that is going to happen, but it is a new area that we are going to kind of start looking at. So that's kind of what the future holds for us. You have drier, longer, hotter summers, more fires, which then feed blooms, which then produce toxins, which then shut down water systems. Yeah?
What are the nutrients that the fires provide?
Nitrogen, phosphorus, and that's something that we'll be kind of looking at. So like I said, there's not a lot of research out there. And so we're trying to design some research with OSU right now that actually starts looking at the storms during the winter and what's being delivered to Cougar, and see if that's actually true. So, and I don't, I'll talk about that in a second. Actually, it's part of the next thing I'm going to talk about actually. So, given that Rosie story, what are we going to do about it? Well, the things that we are working on and actually have in place right now is we are doing some research, which I'll talk about next slide, and it involves OSU. We're really ratcheting up our monitoring approach, and obviously the new rules are forcing every utility to ratchet up with their monitoring. We're developing and already have some real-time tools that we can start leaning into, and we're putting in place. And then we're increasing our analytical abilities to actually see this stuff in a quicker time frame. And I'll talk a little bit about that. And we're also doing some things in our treatment plant that actually will help us in the future. And then finally, this relates to our coordination with the Army Corps. Talk to you real briefly about what that looks like. So I'll go through these fairly quickly, but this is essentially the idea with the OSU study is that if we can get in, and that's a big if, and we've been talking to David Bishop, who we're going to essentially by early next week, we'll be giving him a list of kind of what we'd like to do, just to put it out there and see if it's possible. But part of this depends on you guys completing the bear surveys that shows where the high intensity burns were happening. And based on where those are, and if we can get access, we'd essentially go into here and put in some instrumentation up above or below, or it could be over here, wherever we see some tributaries. And we're looking for 2 tributaries really, that we can put some instrumentation in there to bracket the fire, and we'll just leave it in there. So it'll collect data for all through the winter. And then in addition to that, we'd essentially want to be sampling if we can, and we have up here, here, and at the outfall during the first 4 or 5 major storms, just to see what nutrients are being flushed into the reservoir. And so we'd be looking at essentially phosphorus, nitrogen, carbon, organic carbon, what type of carbon is coming in, metals, bacteria, and just start to get a good sense of what is being delivered to Cougar. So clearly this is a plan that is kind of in flux right now as we figure out, first of all, where it would make sense to do it, and then can we even get there to do this? So it may not happen, it may happen, but that's kind of our hope for the research side.
Is there any way of getting a benchmark in a non-fire, in any of the areas that had not been touched by fire here?
We have a lot of data for these parameters, non-fire data in this area.
You have the baseline.
Yeah, we have a good baseline. We've been monitoring up here for a while. And so yeah, we feel like we have the good baseline, and whatever we do here will help us understand kind of what that added load is from the fire.
So almost everything on the west side of the fire, on the west side of the reservoir, that's all designated wilderness. So
Oh, the
I
east
think,
side over here?
yeah, the east side, I'm sorry. So I think you're gonna have a hard time getting in there and letting us allow you to put instrumentation in there like that.
Right.
So I would concentrate on the west side.
I don't know if there's some opportunities. Well,
Hardy Creek is right around there.
Yeah,
Yeah.
and so.
But if depending how low you do it, like along the 500 road, you're outside the wilderness. So if you don't go too far
Right, if you're down
east,
here.
There's another spot, Walker Creek, with that drainage, you just had the thing on,
Over here?
kind of out of the wilderness there,
up,
and that'd be a really good.
right there. That's Walker Creek.
Walker
Yeah.
Creek right there, yeah.
Yeah, that's.
Because you'd get a lot of fire there. The road has been decommissioned up there, but it's a little piece that's carved out of the wilderness.
I mean, I think these instruments, you know, they're like sondes, you know, so.
Oh yeah, he sent us pictures.
Yeah, so we can hike, you know, we don't have to drive there, we can
Yeah.
hike in, but. And so, and OSU will give us 4 of those, exo sondes, and then.
Yeah, I know Cheryl Friesen's
Okay.
trying to work on making it happen.
Cool, because I know he said he's got to talk, it's Kevin, he's got to talk to HCA and see if he can get help, but. So we're hoping that the next couple of weeks to have some plan and kind of run it through you guys, see what's possible. And if not, you know, at the very least, we'll just be monitoring the reservoir where we can and the outfall all winter long and see what we see during major storms. So that's the research approach we're going to take, at least short term. And we're going to continue doing harmful algal bloom sampling, and next year we're going to be start in April essentially and go through October. This is actually sampling during the fire last week. It's kind of what it looked like. Our sampling, our monitoring includes a lot of different in situ instrumentation that we put in there that looks at a variety of different parameters. We then collect samples that we send off to labs, and we do this net tow where you take this net and you kind of concentrate the whatever's in the water, and then you can look at it through a microscope and you actually see. That's what David was doing actually before he came up here, and you can actually see if you have species that can produce toxins, and if you do, then clearly you can start looking for toxins. But it's a pretty cool way of quickly seeing what is in there. And Jared, you were talking about, I don't know if you want to mention, and Nate, the McKenzie High School students maybe helping with this, but I don't know if that's probably.
Yeah, there was some early planning with that. I don't know if it actually got to the point of actually talking to Nate yet. But what we've done is, starting last year, is Thurston High School has been coming up and sampling the lower South Fork in kind of like an add-on piece to the South Fork floodplain project. And so one thought that we had, when we initially looked at Thurston going upstream of Cougar to do some sampling before it comes into the reservoir and downstream last year, but it was too much of a trek to drive all the way from Thurston up there. So we thought maybe that McKenzie High School, because of proximity, might be able to do that. It sounds like the road 19 is not going to be passable. Big 9's over.
It will be next month, I'm sure.
Well, maybe.
Well,
Yeah, I don't know. Meeting we had earlier this week made it sound a little bit more pessimistic, but potentially, I mean, that one might be a nice little community citizen science student research opportunity to add on to tie into the OSU study if we can get students up there to look into some of those creeks as well, and then tie into the work that the Thurston High School students are doing, kind of work between the two high schools.
Yeah, we've got a group of students ready to go, and a couple of them are sitting back there listening in, so.
Cool.
We can talk more about that, but obviously it depends on access.
Yeah, there's a lot of variables.
Yeah.
So when we say multifaceted, I guess what we're talking about is, we're doing this work every 2 weeks. We've been working with USGS to deploy what they call these spat bags, which are essentially little discs with a bunch of media in it that absorbs toxins, and so you leave it out for 30 days, so it kind of concentrates that, and then you can take it out and actually look at things that kind of flow through during that 30-day period. And then, of course, the microscope is a big, using that to ID what we have. And then what we're trying to do, or hoping to do, is if you go to eweb.org and you go to Source Protection Water Quality, you'll see we have this website that has all of our data on it. And we have a HAB page, a HAB map, where you can click that, and then that essentially pulls up this map of where we have sampled for harmful algal blooms. You can select any station, and then data is there for you to see what's happening. And what Dave is trying to do is have this updated on a more like weekly basis. So we sample it every other week. So as soon as we get the data, get it in the system, so that the public and others can have this more readily available to them. And then looking at real-time monitoring, obviously we talked about that percent flow, and so we're building a web-based tool that takes essentially the gauge data, and it triggers alarms whenever flow from Cougar and Blue River exceed 30%. And so if we have blooms going on, we know that that might be a problem for us at the intake. We also have sondes at Vida and Hayden Bridge that are collecting a bunch of water quality information, which I'll talk about next slide. And then in the future, what we'd like to do is essentially add a buoy in Cougar, and this is just a diagram of one, that has a sonde that goes up and down. This has a solar panel on top. Essentially, it goes up and down and collects vertical information real time, and so we know what's happening vertically in the reservoir. And that's something we threw out to Eric and Greg, and it's a doable thing. It's just going to cost money, and we need to figure it out. So some of the real-time data we're collecting at Vida and at Hayden Bridge includes this thing called FDOM, which is fluorescence dissolved organic material. And so what this does, I'll talk about in a second. So when you have, this is a discharge from, this is essentially the discharge record. So you can see when there's a big storm, your turbidity goes up, obviously, but there's also an impact on this fluorescence. And what we've been studying is essentially what it means. What fluorescence means is that you shine a light into essentially a jar full of water, and what fluoresces off of this from the carbon sends a signal, and that signal really tells you what type of organic material it is. And so FDOM measures that essentially that excitation that comes off of here. And so that tells us a lot about what type of carbon it is, how it fluoresces. And so we've been studying this with the USGS, and essentially I found that there's 5 carbon pools in the McKenzie. And so it could be leaf drop, could be one, represent one, it could be essentially algal bloom die-off could be another, septic systems could be another. But what we found is only certain types of these pools actually create disinfection byproducts. And so from a drinking water treatment standpoint, it's good for us to see essentially when this is happening, when we're getting certain kinds of carbon coming into the system. So we'd like to, FDOM there's a lot of potential there that we think we could use to look at toxins and cyanobacteria. And so we'll keep essentially looking at that real-time data and trying to get a better picture. In fact, we started setting some of our alarms at the treatment plant to, well, not that data, I guess that's to the blue-green algae probe that we have. But so we also have other chlorophyll and other probes that we can essentially see real-time what's going on. And so on the analytical side, what we've done, so I'm now managing our water quality lab at Hayden Bridge. And so we've added, what we can do, and what we've been doing for years, we can analyze for bacteria, nutrients. We can do this UV 254, which is essentially that, it's not fluorescence, but it's that same concept. And the bacteria is one that, we're actually an accredited lab, so it's for regulatory purposes. You can use that data. And so we bought the ELISA equipment to look for cyanotoxins in our own lab. And as soon as they're going to come out with an accreditation program next year, and we'll get that accredited as well, so we can use it for regulatory purposes. And in the future, we're going to add equipment to look for dissolved and total organic carbon. But what this does for us is essentially gives us really quick turnaround. So David can grab a sample, and within either 6 to 8 hours or early next morning, we have results, and we can take confirmation and run it through again. We have the ability to handle samples at a moment's notice. We can take as many samples as we want, and we have really significantly reduced costs. I mean, it's like night and day. and we don't have to wait forever for data to come back from off-site labs. And we have a great QA/QC program there because we're accredited. So, so we've ramped up our analytical capabilities in our lab to actually allow us to see this stuff quicker and react sooner. And then, like I already mentioned, I'm not going to go through this, but we've set up how we're going to, treatment-wise, how we're going to switch things whenever we do see toxins in the water. But we're also doing this biofilter project. It's a pilot with the University of Toronto. And so we're looking at switching our treatment essentially to biofilters where you don't add chlorine at all until after it goes through the biofilters. This is a proven technology for addressing toxins. And so we're running essentially a pilot program right now through some small filters we built to test this concept. And we got a sizable grant with the University of Toronto to kind of see if we can operationalize that. And then finally, working at the Army Corps, basically the preliminary discussions we've had is coming up with these kind of changes that we get information weekly on what's predicted on how the dam's going to operate. And then our monitoring for blooms, we relay that information back to the Corps when blooms are happening and when toxins are happening, when they're producing toxins. Then we try to, if we can, within the margins that the Corps has, is reduce what they're discharging and maybe increase the physical point that the water's coming from. So right now, at least our understanding from Greg is that, you're taking water from the 0 to 10 feet. Can we increase that to 0 to 20 without impacting the downstream temperature for fish? So trying to get more dilution in that outflow while reducing quantity is the idea. And then also trying to get contractor access so we can actually do more efficient monitoring. And right now we have to walk down the whole dam face to collect a sample, which chews up about 30 minutes. We could drive down there, we could get out of there. The whole time we're breathing smoke air, about ready to pass out. And then sharing our data through web and other tools. And that's what I got. Questions? Yeah, Steve.
How many reservoirs and waterways in Oregon evidence cyanotoxins? Any idea?
How many have them?
Well, as far as we know.
As far as we know, Cougar, Blue River, Detroit, and is there any other?
As far as we know, what?
How many reservoirs have toxins or had toxins found?
If you go to the Oregon Health Authority's website, you can actually look back historically over the years, and there have been advisories at a host of reservoirs.
But they're advisories, well, I guess, yeah.
Those are based on toxins. But like Odell had a really high rate. Climate Lake typically
Right.
sees toxins. There's a number of lakes back in the east side of the state.
I think the problem is, if I can go back real quick. I mean, the problem is that when you're in the past, you didn't even look for toxins until you're finding blooms that were way up here. And so we don't really know if these blooms were producing toxins. They could have been producing toxins. We don't really know. And so the advisories that David's talking about, where they actually are sampling, are those really high levels of cell counts that were found in those lakes. Yeah, Chuck.
Are there any currently practical methods out there to neutralize or to destroy the toxin in the home water supply?
Ohio has I don't know if you remember the Toledo, when the city of Toledo shut down their water for like 2 weeks in 2014 because of toxins. What they do is they actually use algicides. They come in, they spray algicides on the lakes, which I don't think we want to do that.
That's also the state that has lakes that have been on fire. So.
Yeah, so, and I don't know, do you know of any other methods, David? I mean, there's obviously, zooplankton, feeding on them helps, but that's more of a natural cycle.
Feed those? Introduce massive quantities of those in there or something?
More predators.
It never works.
Yeah.
Control.
How about the fluorescent?
Yeah.
Does that kill them or?
No, that just allows us to see kind of the properties of what is coming out. So, I mean, it just allows us to see maybe when they're there.
So I had heard on the news during Salem's issue that they were trying to use maybe activated charcoal or something. Did that work? What happened?
Yeah, that worked, and we actually provide them the hopper and the use that, 'cause they didn't have that. We actually provided them the distribution trailers, because they didn't have ways to get water out to the community.
I saw that on the news.
So we had ours up there, and then we also gave them a hopper so they could add carbon into the beginning, the front end of their process. And that carbon does work, yeah. Yeah, Marianne.
So I was wondering about with those temperature control towers in Cougar, before those were in, when the water was coming out the bottom, was this less of a problem, or?
You know, I don't know, Salem has problems quite a bit with, maybe with diatoms and organic matter, but do you know if they had toxin issues?
No, I meant on Cougar.
Oh, on Cougar, I thought you said Detroit, sorry.
No, Cougar.
Well, the guess would be that, yeah, you would probably have a less, well, but that's, yeah, I don't know, because we're seeing that Blue River, you know.
And that comes up more at the bottom?
Yeah, that's coming out the bottom.
So one thing, I mean, we see far less intact cyanobacteria cells coming out of Blue River, because it is coming down from so low, a lot older. Cougar, on the south fork, we do see some of those cyanobacteria coming out, because we're pulling up much higher. But Blue River's had higher toxin levels, for the most part. So the toxin formation is kind of, the bloom could be in some different part of the reservoir, as long as that's still mixing well. Whether it's coming out at the bottom or out the top. But those certainly depends on the reservoir.
Because once the cells produce a toxin, then it's dissolved in the water.
Oh, okay.
It kind of moves separately than the cells.
It doesn't stratify with the cells necessarily?
Not necessarily. It depends on the mixing. Yeah.
And we just got word too today, the Corps is actually coming back to Blue River and Cougar next year. They're going to be doing their monthly synoptic. So every 5 years, they try to hit a new pool of reservoirs, which is really good timing for us. They'll be out there every month with a boat, and they do quite a bit of sampling as well. They also actually would like to partner with some of the fire monitoring, so next year might be a good year.
Did you have a question, Kelly?
I did. So, the question was asked earlier about obtaining some baseline information, and you said that, you guys, but considering that you weren't looking for the toxins, is that?
Yeah, but what I meant was around nutrients and organic carbon and bacteria, we have that data. So when we start looking at fire effects, adding more nutrients, that's what but you're right, we don't have the toxins.
And when you were looking at the cells themselves, were you actually differentiating between the types that create the toxins and not?
Yes.
Okay.
Yes. Yeah, we do that ID enumeration. It's called where you figure out what is there, what species, genus, species, and yeah. I'm kind of learning all this from David. Really, he should be the one up here. Yeah, Chad.
Did any of the other utilities upstream of Salem that draw the St. Maur out of North St. Anne, did they have any issues, or was it just Salem that?
I don't know. I don't know if they actually draw off of the river or if they're groundwater. I think they're mostly groundwater, but I didn't hear of anything. Anything else?
Yeah. Do you know if any residents take drinking water out of the McKenzie?
Surface water?
Yeah.
I don't know. We have intake data, but I don't think it's any surface water intakes. I think they're all groundwater wells.
Some of them are pretty shallow groundwater.
Yeah,
I was going to say, some of them
Really
20-foot wells right next to the river.
Right.
So,
Yeah, I don't think so, but it's a good question.